Hi, my name is Michelle and I'm going to be walking you through Experiment 50B, the synthesis of caramel from milk and sugar. This reaction is called the Maillard
is a word of French origin. In French, it is said as Maillard. Maillard. This name is famous for...
This reaction occurs between a nitrogen-containing molecule such as protein and a reducing sugar. A reducing sugar has hemiacetyl groups which allow it to act as a reducing agent. So, in terms of our experiment, the N-substituted molecule is going to come from the proteins in milk, and table sugar is going to be acting as our reducing sugar. So let's go over the mechanism of the Maillard reaction. The first step of the reaction occurs between the carbonyl group of the reducing sugar and the amino group of the protein. This forms an N-substituted glucosamine, and also water as a byproduct. Using this knowledge, we can accelerate the reaction by using high temperatures. What this does is increase the rate of water evaporation, thus lowering the concentration of water at the product end. We know that by Le Chatelier's principle, this would accelerate the rate of the forward reaction. However, using temperatures that are too high may cause the formation of acrylamide, which is known as a possible carcinogen in humans. This compound forms between a dicarbonyl and the amino acid asparagine. So for this recipe, we used sugar, cream, butter, and a little bit of salt because it's salted caramel. We're pouring that sugar in, and then we heat it to medium heat. So we're stirring the sugar on the pot to ensure an even distribution of heat, otherwise the sugar would burn, which we do not want.
Very cool.
Very cool. So as you can see, the sugar is starting to form clumps and then melt. What we're observing right now is a reaction called sugar inversion. So sucrose is a disaccharide, and we're witnessing it being broken down into its monomers, which are fructose and glucose, through a hydrolysis reaction plus heat. This is necessary because sucrose is not a reducing sugar and glucose and fructose are. So although they are very similar reactions, this caramelization reaction of the sugar is actually not the Maillard reaction because there is no nitrogen-containing molecule, or in our case, protein. So that's actually coming from our butter, which I forgot to mention earlier, and also our heavy cream.
I'm gonna throw it away.
Oh, the bubbling. Make sure you get the bubbling. I have to talk about the bubbling.
Okay.
Now we're talking. This is the Maillard reaction. So the bubbling is just from the temperature difference in both substances, and they are just kind of fighting to reach an equilibrium. This looks like peanut butter. Peanut butter?
After how long do we just accept it as how it is and add the cream?
I think it would be funny. I think we should just leave it. Bro, I swear to God.
I think we just have to add the milk.
So this is definitely a step that would lower our percent yield, and it is a source of error. The temperature was definitely too high and caused the sugar to not incorporate with the butter, and adding the cream was not a good idea. I think this could have been helped by using a bigger container so that we could stir it better without getting butter on our fingers, hot butter.
Okay, it looks good. No stirring.
So as you can see, after some time of taking the pot off the heat, thus lowering the temperature, and continuing to vigorously stir, we managed to bring the mixture into one homogeneous state. And now we're adding salt. So at this point, you can kind of see that the mixture is pretty characteristically brown, caramel colored, and this is a product of the Maillard reaction, which is responsible for the change in the color and the flavor that we know is unique to caramel. So now that the mixture has been taken off the heat for a while and let to cool, we can see that it is starting to condense in the absence of heat. I would say overall that the Maillard reaction between cream, butter, and sugar was successful. And thank you for watching.